This is a lecture on Haskell Comprehensions for Comp 360 programming languages at North Carolina A&T State University. Well, I guess we're in trouble. Be sure to keep reading the Learn You a Haskell website, at least past the starting out page and on to the next one about types. Keep reading Learn You a Haskell. It's better than this. Continue to read the website and write Haskell programs. A review of lists. Lists are probably Haskell's primary data set. Haskell allows you to create lists by putting elements separated by commas inside square brackets. All the elements have to be the same type. Strings, which you can write with double quotes around it, are lists of characters. You don't have to separate the characters by commas. There are several operators on lists in Haskell. You can concatenate two lists or put them together to make a bigger list using the ++ operator. If you want to add one element to the beginning of a list, you can use a colon. Note that a colon adds an element to another list where ++ combines two lists. And then double exclamation points will get you the nth element. Elements are numbered starting at 0 like every other computer language. There's a bunch of list functions. Head gets you the first element and tail gets you everything but the head. Last gets you the last element and init gets you everything but the last element. Length obviously returns the length of an element. Null is useful for functions. Null returns true if the list is empty. A lot of recursive functions in Haskell iterate until the list is empty. The reverse function reverses the order of the elements in a list. Take takes a number and a list and then returns another list that has that many elements in the beginning of the first list. Drop is similar, only returns a list without the first n elements. Maximum gets the biggest and minimum gets the smallest element in a list. An ELEM is useful. It returns true if the particular element you specify is in the list. Lists can contain lists of lists. Remember that all the elements in a list must be the same type. So if you have a list of characters, then the other lists in that list must be lists of characters. A list comprehension is a means of creating a list. A list comprehension is written inside square brackets, and there are three parts. An output function, which includes what values are being included in the list, a vertical line, and then an input set, that is the list of elements that will be included in the output function, and then optionally a predicate. If the predicate is true then the output values will be included in the list. If the predicate is false, then those output values will not be included in the list. Here's an example where we have a list comprehension that creates a list of the squares of the numbers from 0 to 5. So on the left, the output function is x times x, and it's drawing from the input set where x, and then we have this arrow. So all the x's that are in the list 0, 5 will be included in this output function. So first it's 0, then it's 1, then it's 2, and it will create the list shown here. This one doesn't have a predicate, but if we could add a predicate here, let's say we only wanted the elements that were less than 50. So we could include the same thing, and this will return the larger list. List comprehension is really useful for creating lists. You can perform a function on all the elements of an earlier list to create a new list. Here we're using the successor function for a character. Successor gives you the next character. So the successor of A is B, the successor of X is Y, and so forth. So we take the successor of cat for all cats in the list, dog. And here's an example. We upchar Aggies, we get I upchaired Aggie Pride, I get That's quite a mouthful. So try this. Write a Haskell list comprehension that will multiply all the elements in a list by a given number. Here's a possible solution. We have the multiply by Haskell method, and it contains a list, LST is list, and a number, and it will then, for each element in the list, we'll multiply that element by the number. So there's a definition, and then we can try the function by calling it with a list and a number, and we get the return value where we've multiplied each element of the list by the number. And it works with any number, including negative numbers. Remember, when you have negative numbers, it's a good idea to put them inside parentheses. Otherwise, Haskell will think you're going to subtract 3 from this value, and that's not going to work. That's another example. Imagine we want to take all the lowercase characters out of a string of characters. Remember that a string is really just a list of characters. So in this list comprehension, we take all the characters in the list, and they'll be output if that character is not in the list lowercase a through lowercase z. And so we try it, and put my name in here, and we just get the first category list, put it in here with North Carolina A&T State University, and I get all the uppercase characters and none of the lowercase characters. The spaces are still there because the spaces are not lowercase. But what if we wanted to take out those spaces? It might be nice to be able to remove the spaces too. So I've extended the function here, same as before, for all the characters in the list cat, if they're not in the list A through Z, or they are not a space. And there it goes. You can see I can put it out big, and it takes out and just gives me the abbreviation. Try writing another list comprehension function yourself, where we're going to take all the non-vowels out of a sentence and return just the vowels. Remember that the ELEM method, we go ELEM, an element and a list, returns true if that element is in the list. Try writing this yourself. Okay, here's a possible solution. It's similar to the previous ones we saw, where it takes a sentence, and for all characters in that sentence, if that character is in the list of vowels, and I had to put it in both upper and lower case to include all the vowels. And then we try it, and we type it in computer science, and sure enough, it gives us the O, the U, the E, the I, the E, and the E from computer science. Now, list comprehension can take multiple lists, as many as you need. Remember, of course, that if you have a list of n elements and a list of m elements, then using them both, you're going to get n times m elements, which can be pretty large very quickly unless you filter them out. In the example here, we have two lists, cat and dog, and then for every element in cat and every element in dog, you get the element from cat concatenated with a space, concatenated with the element from dog. So I tried it here with comp and electrical and engineering and science. It's going to mix these together. We get computer engineering, computer science, electrical engineering, electrical science. Notice that we have the comma here, which is not separated predicate. These are two separate list inputs. A different data type in Haskell, similar to lists, are tuples. Tuples, unlike lists, can have different data types. In a list, every element of the list has to be the same data type. In tuples, you can mix them. In the example here, these two tuples have a number and a string. Now, if you have a tuple that's a number and a string, that's a data type, a number string tuple. And if you're going to put them into a list, all the elements of the list have to be the same, so all the tuples would have to be number string tuples. You couldn't mix a number string tuple with, say, a string tuple. There are a couple handy Haskell functions that you can use with tuples. First or first gets the first element of a tuple, and second gets the second element of it. Zip is interesting. Zip will take two lists and create a list of tuples combining elements of both lists. If they're not the same size, it will just truncate after it comes to the end of the first list. What about tuples with more than two elements? Be calm. We'll handle that later. You can use list comprehensions to create tuples. In this example, the output function contains parentheses, so these will be tuples that will be created, two tuples. And first one is all the elements from cat and all the elements from dog, or the cat is the list of integers 1, 2, and 3, and the dog is 0, 1, and 2. And so we run it, we get all the combinations of those two. Try writing your own list comprehension that will compute all the right triangles that can be made with integer edges less than 20. This is similar to the example given in the Learn Your Haskell website, but slightly different. Pause the web until you get this one finished. Okay, when we want to do this one, we need to create a list comprehension that's going to go through all the possible numbers, all the C's that can be from 0 to 20, all the B's they can go. You don't need to go from 0 to 20. You can go to 0 up to C, since B can't be larger than the C, where C is the hypotenuse. And A also cannot be larger than C. In fact, it can't be larger than B. Also, if it's a right triangle, the Pythagorean theorem has to hold. That is, sum of the square of the two sides equals the square of the hypotenuse. So here's a list comprehension that does that. Again, we are making tuples, A, B, and C. And C comes from the numbers 1 through 20. B comes from the numbers 1 up to C, since it can't be that. And A comes to the numbers 1 through B. And then a predicate is that A squared plus B squared equals C squared. And so when I run it, I get the list of all the right triangles of integer values whose edges are less than or equal to 20. And you'll notice that some of them are multiples. In other words, the 3, 4, 5 triangle, multiply that by 2, you get the 6, 8, 10. Multiply by 3, you get the 9, 12, 15. Multiply it by 4, you get the others. But there are two other tuples, the 5, 12, 13, and 8, 15, 17, that are unique. Did you comprehend that comprehension? Be sure to read learnyourhaskell.com.